Hi, I am Ele313. This is the first experiment of Ele313. Before we start, use safety goggles.
First, I want to check my components. If you look at from flat side of the transistor, most left leg is emitter, then middle is base, and the last one is the collector. To test the transistor, we can use diode mode of the multimeter. If the both base collector and base emitter junctions are giving us VD-on value, which is 0.7 volts, the transistor is okay. Otherwise, we cannot use the transistor. This is okay. This is also okay.
The second step is checking the resistors. I have turned on the ohm meter mode. These resistors have 220 ohm value. These probes have a resistor value about 9 ohms, as you can see. Let's check this resistors. It's about, yes, and this one. Okay, these are alright. Then we'll use 3 of them, 2.2 ohms. So check 4 times. Okay, it's about 2.2. This one is also 2.2 almost. This one is also. And last one. This one, okay. Then we'll have 4.7K. Okay, this is right. And how many 10K? Once. 1 10K. Okay, this is also. And 2 32K. Once. Okay. This is also okay. And the last one, 220K more resistors. Yes, this is okay. And this is also okay.
Let's control the capacitors.
This is the capacitor one. All capacitors having 10 microfarad value. This is okay. This is also okay. Also, this is also okay. This is okay. And last one. This is also okay. And I want to check the battery also. DC voltage mode. And okay, this is almost 10 volt.
Let's set up the circuit and let's start. First, place the first transistor. I'm gonna use some wires to represent the terminals of the transistor. The orange wire for base, green wire for collector, and the yellow wire for the emitter. Okay, then we can start with the voltage divider selected base of the transistor. 33 ohm kilo resistor from base to ground, which is here R2. R1 is 120 ohm kilo from VCC to base. Okay, and input capacitor from base to some breadboard, and RC1 10 kilo from VCC to connector, which is green jumper here, and RE1 2.2 kilos from emitter to somewhere in the breadboard. and emitter capacitor parallel with the emitter resistor. Okay.
We connected R1, R2, RC1, RE1 and our transistor CE1, CI. Then the first transistor connections of the first transistor is done. I'm gonna connect the feedback network later.
I'm gonna use a capacitor here, which is connected from collector to first transistor, output of the first transistor, and input of the base of the second transistor. And let's put another little wire, jumper wire, to separate the input. Okay, and I forgot my glass. Okay, now place the second transistor. The orange wire, as you can remember, over base of the transistor. Okay, then a green wire for collector, and yellow wire for the emitter. Okay, second transistor is already placed. Then make the connections of the second transistor. R11, R22, RC2, and RE2. Okay, R11 is 120 kilo from VCC to base of the transistor. R22 from base of the transistor to ground. Okay, then RC2, which is 4.7 kilo from VCC to collector. And RE2, 2.2 kilos from emitter to direct ground. Then CE2 capacitor to parallel with RE2. Okay. And last thing we have to do is connecting the feedback network from output of the second transistor to emitter resistor of first transistor. For the output capacitor, I'm going to use this one, which is 10 microfarad. And connect the feedback, I'm going to use this one, like jumper wire, from here to. Okay, I'm going to place RF2, which is here, from collector of the second transistor, output of the second transistor to output of the second transistor to emitter resistor of the first transistor, which is 2.2 kilo ohms. Okay, then the RF1, which is here, from this node, emitter resistor of the first transistor to ground. 220 ohms from this node to ground. Okay. We have done all of the connections.
I have calculated the output resistance for feedback, output voltage for the feedback and feedback circuit, which is 2.35 volts, which we expected. And place the power connections. Okay. Okay. Then make the turn on the voltmeter, and our output is here, which is second transistor's collector. Okay, exactly the same with my calculations. 2.35 almost. Before we start measuring the current, let me write down the value of the VO. Then connect our main breadboard. Then we will measure the currents of RC1, RC2, RE1, RE2 and RF2. First start with the RC1. The advantage of the using wires, jumper wires, is we can easily disconnect the branch and measure the current in this branch. And from RC2 to collector, okay, I forgot the power connection. And check this branch. 0.49 milliamps, almost 0.5.
Okay, this is my clamp. Check this out. Okay, this is milliamps. 0.49 milliamp. Okay, write this value to the, yeah, 0.49 milliamps. Okay, the next current we'll measure is the RE1. For the RE1, we'll replace this one and measure the current current. 0.49, almost the same with ICQ. You know that beta plus 1. And 0.49 milliamps. Okay, then RC2, which is here. Okay, let's measure 1.57 milliamps. Remember that the curve from VCC to RC2 is divided into two branches, which is the network and the amplifier transistor, connector transistor. This is 1.57 milliamps. Okay, let's write down this value too. 1.57 milliamps. Okay, go back to breadboard. And make the connections again. And the last two branches are emitter, resistor here. And total source, a connector and emitter. 0.68 milliamps. Let's write down this also. RF2. Which one was RF2? RF2, which is 2.2 kilo ohms. Okay, go back to breadboard and replace the feedback. Right here, and make the connection of the emitter. Okay, what's that? Okay, and we measure the current in this range from collector to second transistor to RF2. 0.8586 milliamps. Okay, we're done for the first circuitry. In the second part of this circuit, this measurements will measure the entire whole circuit with the 3.7 kilo ohm resistor, which is RF2. Okay.
In this part, we will be replacing this RF2 with 3.7k ohm resistor. But before the start, I'm gonna tell you, I write down the RC2 value to RE1 and RE1 value to RC2, and I have replaced these two values with its correct point. Then we can start. I don't have any 3.7k ohm resistor, but we can use a combination of different resistors. But for sake of easiness, I'm gonna use a potentiometer which is 10 kilo ohms. By adjusting its value to 3.7 kilo ohm,
as you can see, I have adjusted this value to 3.7 kilo ohms, and I will use this one. No, use this one. We have replaced this RF2 with 3.7 kilo ohm resistor, as the experiment says. Okay, now we will measure the Vout and this current. Okay. Voltmeter and the power of the circuit. Now what volt is? 3 ohms. 3 volts. Sorry. Sorry, again, the same. Okay, now we will measure RC1, RC2, RE1, RE2, RF2 currents. Okay, again replacing it. Collector, resistor to collector. 47, 48 milliamps, 0.48 milliamps. RC1 and RC2. From RC2 to collector. 1.20, 1.32 milliamps. 31, 31. 1.31 milliamps. Now the emitter currents. RE1. From emitter to emitter resistor. 1.48, exactly the same with RC1. Okay, and RE2. 0.62 milliamps. And the last one is RF2. 0.69 milliamps.
Okay, all of the measurements, current measurements is done. Then we can pass the second question. In this part, we will be measuring these values without a feedback network, but its loading effect. To do that, we should know the type of the feedback. As you can see, in the lecture notes, example 1.3, there is an example of the circuit which feedback type is exactly the same with our experiment. Then we can use this one as our guide, and its loading effect is like that. The output resistance R2, effect of R1 and R2 to the output is series. This is parallel sampling, which is voltage sampling, and the mixing is the series, as you can see here.
Now we'll make a circuit, and let's see if it's works. Now I'm not going to replace all of the components. I'm just replacing the feedback circuit. Okay. RF1, not RF1, this is RE1. And this is RF1. Okay. We replace the feedback circuit, and we will use only its loading effect. To do that, as you can see, for the first stage, the feedback resistors are parallel with each other, and from emitter to ground. So we'll set up this portion of the circuit. RF1 from emitter resistor to ground, and RF2, which is 2.2 ohms from emitter resistor to ground also. Then these two resistors are parallel with each other, and series with the emitter resistors. Then the effect of the feedback network, so output to second stage, then as you can see, the output of the feedback network is series with each other, but parallel with output. Now set up the circuit from VCC collector of the second stage, out of the second stage, to summary the breadboard, and our trace. Okay. As you can see, R2, R1. R2, R1, okay. Now, let me measure the voltage and currents before it starts. And the voltage will be and make the power connection, and output voltage will be out. Okay, from collector to ground. It's 2.23 volts. 2.24 volts. Okay. Then the turns. Okay. Let's start with RC1 again. 0.55 milliamps. RC2. 1.51 milliamps. Okay, then RE1. So let's RE1. 0.55 exactly the same with RC1. Okay, and RE2. 0.59. Okay. Then it says RF2, but there are two RF2s. I'm going to measure both of them. First it's the RF2 for the first one RF2 is 0.05 microampere. 48.7 microamps for first circuitry, first stage. Which counts. 49. And for the second circuit, so the second half stage, it is 0.92 milliamps. Okay, this part is done, and then for the second stage, second part of the question, we'll use again potential meter. which is ours. Okay, this one's okay, and then this one. Okay. No, replace ours too. Wait. No. Okay, and then the ours. Okay, and last ones. And for this one. This one, sorry. Okay, so now you'll need your output voltage, which is here. 2.22, 23 volts. 2.23. Then turns. 0.55 milliamps. Right on. Okay. RC2. Okay, 34 milliamps. Okay, RD1. 0.55 milliamps. And RE2. 0.59 milliamps. I'm not going to measure the first part of the circuit because there is a little tiny current going through the RF2, which is negligible. So I'm going to measure the second part of the circuit. 0.75 milliamps.
Thank you for watching my video.